Danger zone! Hi everybody, I'm Shea Zuckerman here with the FutureMaker Lab to talk to you about how to fly an airplane. So I have with me here the WSU Tech hangar and a big old business jet to help me explain the 4 forces of flight. So there's 2 forces that everybody's experienced before. If you've ever driven in a car or you've ridden a bike or anything like that, you've experienced a force that propels you forward. That's thrust. And then you've experienced drag, which is the air pushing against you, trying to impede and keep you from moving forward. So drag is not a good thing. We don't want drag, but it's a natural part of physics and we can't really help it. So we just accept that drag is part of the deal. To make an airplane fly, we got to be able to go up. Cars don't do that, right? So there's 2 more forces involved to make an airplane fly. There's lift. That's the force that our wing right here creates to push the plane up into the air. And then there's also the weight of the plane. Everything around us weighs something. Even the air we breathe weighs something. So that weight with gravity tries to pull the plane back down. So there's constantly has to be lift to make the plane fly up. So 4 forces, right? Thrust forward, drag backwards, lift up, and weight down. So here I have a little miniature version of the big full-size plane behind me to give you a better feel for the different forces that make up flight. So we've got our wings. The wings create the lifting force that moves up. We have 2 more wings actually on an aircraft. You've got the vertical stabilizer right here. That's actually a wing also. And then you have the horizontal right here, the tail, that actually acts like a wing also, but it acts in reverse to these wings. And then of course you've got the engines. On this plane, we have 2 of them, just like the one behind me. These create that forward thrust, and drag is created by moving through the air. So you can actually try this. Next time you're in a car, roll down your window, stick your hand out and turn it like this to the wind and feel how much the wind is pushing back on your hand. And then turn it sideways against the wind like this, like a wing cuts through the air, and you'll see 2 things happen. There's a lot less force pushing your arm back, that's less drag, but you're also gonna feel a little bit of lift because you're turning your hand into a wing and actually creating that lift. So you can try this when you're in the car. So the things that create drag on this plane that impede our forward motion, keep us from moving forward, are all of the air being pushed out of the way by the plane. So as we move through the air, the faster you go, the more air you have to move out of the way as you move through it, and the more drag there's gonna be. Cars suffer from this too. That's why if you're into sports cars and you're into going fast on the ground, typically it's difficult for cars to go above 200 miles an hour because they get to a point where there's so much drag that you need so much horsepower and so much thrust to push through that it's almost impossible to get. All right, so let's look at how a wing is shaped that makes it so it's possible for it to literally suck the airplane up into the sky. So if you look at this wing, we're gonna look right down the middle of it right here. The best way to see how this is shaped is looking at the very wing tip at the very end of the wing. It's hard to see how this is shaped anywhere else. But if we look at this, you can see the bottom of the wing is curved a little, but it's mostly flat. It's kind of flat. It's a little bit curved, but it's mostly flat. And if you look at the top of the wing, there's a much steeper curve over the top of this wing. So the bottom is pretty flat and the top is kind of curved. And we'll put a picture in here showing you an airfoil, which is essentially a 2-dimensional version of a wing. So we're looking, if we were to just take a knife and slice off the tip of this wing, we'd have an airfoil. And that's that shape that makes it special. So if you look at this airfoil, you'll see flat on the bottom, curved on the top. What this does is this uses the Bernoulli Principle. So check this out, this is cool. When we push this wing through the air with the thrust from those engines up there, as we move this wing faster and faster, air is getting pushed over the top and under the bottom. And the air going under the bottom, if you remember from math class, what's the quickest way from point A to point B? It's a straight line, right? So the air on the bottom has a straight line to get from the tip to the tail of this wing. So it has a shorter distance because it's flatter on the bottom than the air on the top. So that when it splits in the front, the air on the top has a longer distance to get to meet the air on the bottom. And air likes to stick to itself. So the air coming across is going to try to meet at the end. Well, guess what happens? When you have a longer distance to go, the air on the top has to speed up to meet that air at the back coming from the bottom. So guess what happens, guys? That means that extra speed creates lower pressure. So faster moving air, lower pressure, this actually creates a vacuum that literally, as you pick up speed, sucks this wing up into the sky, just like a vacuum. So next time you get your vacuum out, put it on your hand. That vacuum suction is being created by this wing and pushing and literally sucking the plane up into the sky. And that's how lift is created. And that's what pilots use. Pretty cool, huh? So that's the basic 4 forces of flight. If you're interested in learning more about aircraft, you can either be an aircraft mechanic learning how to fix these planes, or you can be a pilot who actually uses the forces we just talked about to make these things fly. Either way, if you're interested in learning more, check out the Bernoulli Principle and fluid dynamics. These are physics topics that aeronautical engineers typically get into, and you can learn more about them yourself. So that's all I got for you today. This has been Shea with the FutureMaker Lab. Make sure to like and subscribe, and we'll see you on the next one.